Today we're going to be looking at the unit circle, actually today, tomorrow, and a few days after that. The unit circle, as you'll recall, is a circle who is defined by having its center at the origin and its radius of 1. So that length right there is 1. As we learn about the unit circle, we need to make a definition for ourselves of a reference angle. That the terminal side of theta makes with the x-axis. And I would love to have us think about this. We're going to set up a little reference area for ourselves here. If theta is in the first quadrant like this, then we can use theta as its own reference angle. So if we're in Q1, the reference angle is theta. Right? It's between 0 and 90, where we need it to be. If our angle theta happens to be in the second quadrant, like that, then its reference angle is the acute angle that makes with the x-axis. So our reference angle in Q2 would be 180 minus theta, or if we were in radians, pi minus theta. If we happen to be in Q3, that's not an equals, that's an arrow. If we happen to be in Q3 on our terminal side, so we have an angle that ends or stops there, like this one, here's theta, but we need the acute angle that the terminal side makes with the x-axis. So that's the acute angle that we need, and that would be theta minus 180, or if we were in radians, theta minus pi. Lastly, in the fourth quadrant, so down here, here's our big angle theta. The reference angle, however, is the one that the terminal side makes with the x-axis, so right here. And that would be 360 minus theta, or 2 pi if we were in radians. Very good. You've got some terminology down for reference angles. We're going to write definitions for the 6 trigonometric functions, where t is an angle measure, and you can see I have it pictured here. P is a point whose coordinates are x and y, where the terminal side of the angle intersects the unit circle. If you think about that for just a minute and drop yourselves a little perpendicular, if this is the coordinate xy, then this x distance is xy, and the height there is y high. We're in the unit circle, so the radius or the hypotenuse of this right triangle is 1. The sine function, I know that you are familiar with having it defined or abbreviated sin, so the sine of angle t. And if you think about that in terms of the right triangle that we're looking at across, sine is opposite over hypotenuse, so y over 1, or just y. The sine of angle t will be y. The cosine of angle t, well, cosine is adjacent over hypotenuse, so cosine would be x over 1, or just x. Sine correlates with y, cosine with x. The tangent function, you'll remember from your right triangle trigonometry, takes opposite over adjacent. So the tangent for angle t would equal y over x in terms of coordinates in the unit circle. The cosecant, folks, the cosecant is the inverse, well, it's the reciprocal function to sine. Cosecant and sine are reciprocals of each other. So the abbreviation for that is CSC, and the cosecant for angle t is the reciprocal of its sine, or it would be hypotenuse over opposite, 1 over y. The secant is the reciprocal of the cosine, so these two go together. and that means that the secant, that's abbreviated SEC, will be hypotenuse over adjacent, or 1 over x. And lastly, the cotangent function is the reciprocal of the tangent. So these three go, or those two go together. And the definition for the cotangent function of some angle, it's adjacent over opposite, so that would make it x over y. And we're looking at the 6 functions of trigonometry and their definitions on a unit circle. Let's see how we're going to use that. This says that we should find the value of the 6 trig functions at t. So I hope we're going to remember that if this point P has its x-coordinate as root 2 over 2, and it has its y as root 2 over 2, those are kind of ugly numbers, but the hypotenuse here is 1, and we're in a right triangle. So we're going to go first for the sine of t, and sine is, according to the definitions that we just made, opposite the angle divided by hypotenuse, and root 2 over 2 divided by 1 is just that. The cosine of angle t, well, that's the adjacent side over the hypotenuse, so root 2 over 2 over 1 as well. The tangent here, well, folks, those that would be y over x, so root 2 over 2 all over root 2 over 2, well, any number divided by itself is 1. So the tangent at this particular location for t would be 1. The reciprocal functions, one thing that I can do to remember which goes with which, each of the groups has one co in it. So sine doesn't have a co. That means that cosecant is the one that goes with that. The cosecant function is the reciprocal of sine. So if we flip the sine upside down, 2 over root 2, well, I know you're not supposed to leave that root 2 in the bottom. We're supposed to rationalize the denominator by multiplying top and bottom by it. So we end up at 2 root 2 over 2, but that's a reducible fraction. So that means that the cosecant for that particular angle is the square root of 2. The secant, which goes with the cosine, is also the reciprocal of cosine, so 2 over root 2, and we'll just cut right to the chase. We know that that's going to simplify to root 2. The tangent's reciprocal function is cotangent, and the reciprocal of 1 is 1. So there are the 6 trig functions for this point. Now we're going to ask you to stretch a little bit and think about your geometry. Remember the 30, 60, 90 triangles? We can use that to find the value of the 6 trig functions when t is 60 degrees. If you'll recall, we're in a unit circle, so that radius right there is 1. And the short side in the 30, 60, 90 is half of the hypotenuse, so that's 1/2. The long side in the 30, 60, 90 is the square root of 3 times the short side, square root of 3 over 2. Now we have values for x, y, and radius, and we want to write the 6 trig functions for that angle. The sine of 60 degrees would be opposite over hypotenuse, so root 3 over 2 all over 1. The cosine for 60 will be adjacent over hypotenuse, or 1/2. The tangent at 60 is the same thing as y over x, so we're talking root 3 over 2 over 1 over 2. Clear that up by multiplying top and bottom by the reciprocal of the bottom. Everything cancels here, and we're left with the square root of 3. The cosecant, well, root 3 over 2, flip it upside down, multiply top and bottom by root 3 to clear up the radical in the denominator. 2 root 3 over 3 is the cosecant. The secant of 60 is the reciprocal of its cosine, so 2 over 1, or just 2. And the cotangent is the reciprocal of root 3, so 1 over root 3, but you know you can't leave that there, so we're multiplying top and bottom by and we end up with root 3 over 3. And there are the 6 trig functions when t is 60. Lastly, we're going to look at doing a similar project when t is 30. So if this is 30 degrees, this is 1, and the short side, the side across from the angle, is 1/2. This is root 3 over 2. We want to do a similar strategy to find the values of the 6 trig functions when t is 30. In a unit circle, the radius is 1, and the short side is half of that. The longer side is root 3 times the short side, so root 3 over 2. And I'm betting that some of you are saying, hey, those numbers look familiar. Well, they should, right? The sine of 30 is its y value, that's 1/2. That means that its cosecant, which is the reciprocal, will be 2. The cosine of 30 is the x there, root 3 over 2. The secant will be the reciprocal of that, and that's 2 over root 3, but by now we know that's going to 2 root 3 over 3. The tangent for 30 degrees is y over x, so 1/2 over root 3 over 2. We multiply top and bottom by the reciprocal, so we're multiplying by 2 over root 3 by 2 over root 3. Bottom cancels, and we're looking at 1 over root 3, which, you know, by simplifying is going to become root 3 over 3. The cotangent of 30, well, I'm going to go back to the easy one and say it's the reciprocal of that function, or that fraction, makes it just the square root of 3. So as you consider the trig functions sine of t and cosine of t, what about domain? Is there any limit to the x that you can put in here? Or x would be the, or t, sorry, would be the angle measure. And we can go infinitely in the positive direction and the negative direction. So the domain for both of those is negative infinity to infinity. The range, now that's a different story. In fact, I have to change my symbol because the highest that you can get to, if you think about this, is 1. And the lowest that you can get to is -1. So our range is from -1 to 1 for both the sine and the cosine. That's the end of our lesson today. Please go out there, do the U-try, and I'll see you in class.